Okay, I would venture to say that this is probably the most conceptually important video that we will have in the entire class. This is where true thinking happens, as I wrote here. And it's going to be really important as you go through this video that you don't just kind of nod your head and say, oh, yeah, okay, that makes sense. But to really try to engage in the thoughts and the conceptual understanding that goes behind some of the developments that we're going to make today. And the 5 questions that we're going to be looking at, and these are really critical questions in the topic of calculus, are the following. What is always true? What is always true when the function is decreasing? So if you think about some function, the function is decreasing when it's going down. That's decreasing. So what's always going to be true when the function is decreasing? What is always going to be true when the derivative is 0? So let's think about, when the derivative is 0. So if dy dx equals 0, what does that mean? It has a slope of 0, so it's a flat line. Where is that occurring? Looks like it might occur there and there. So what's always true when the derivative is 0? What's always true when the derivative is positive? So when the derivative is positive, that means that the slope of tangent line is positive. So where is the slope of the tangent line positive? Well, here it's positive. Here it's positive. So if we're thinking about when the derivative is positive, what's going to be true about the function? Just as you're following along, we're going to go and actually answer these questions pretty concisely, but right now, these are the 5 questions that we're going to be looking at. The 4th question, what happens when the derivative goes from positive to 0 to negative? And this is a real big question that will come back over and over again. But if the derivative is positive, if we think about f prime of x being positive, then 0, then negative, if it's positive, that means that it has a positive slope, so it's going up. If it has 0, the slope is 0. And when it's negative, that means it has a negative slope. So I took information about the derivative, and I'm making a picture of the function. So what do we think we have there? Okay, and the 5th question, what is happening with the function when the derivative has a maximum? And this is a much bigger question, so we'll get back to that in a little bit. Okay, so in order to answer these questions, we're going to be using the n-deriv function. And we're going to be using n-deriv of my given function x comma x. So I'm going to be graphing the derivative function and comparing it to the function itself, and as a way to answer these questions. Okay, so we're looking at the function f of x equals 1/2 x cubed minus 5x. That's what's put into y1. And then in y2, I'm just graphing the derivative function, or f prime of x. Same notation, well, different notation, same idea. And we want to know what's always true when the function is decreasing. So here's f of x, here's f prime of x. And where is it decreasing? Well, it's decreasing. The function is decreasing right here. Decreasing meaning that it's going left to right, going down. So left to right. When you go left to right, the y values get less. So when my function is decreasing, if I look at this range on my derivative function, that's here. So when my function is decreasing, all of my derivative values are below the x-axis. Or in other words, when my function is decreasing, every derivative value is That's visually what's going on. But more mathematically say it, our derivative is going to be less than 0. Less than 0 meaning everything below here is less than 0. Everything up here is greater than 0. And why does that make sense? Well, what this is saying, remember that the derivative is really slope of tangent line, and the slope of tangent line being less than 0, meaning the slope of the tangent line is negative. And that makes sense graphically, because if we go back to the original function, every tangent line here is going to be negative because it's going downwards. So the first big idea, whenever the function is decreasing, going down, the derivative, which is the slope of the function, must be less than 0. And we could, without having to do too much extra thinking, draw the parallel, which is when the function is increasing, the derivative, or the slope of the tangent line, must be greater than 0. This is just a parallel to the rule that we just developed before. Okay, what is true when the derivative is 0? So we're looking at the same function, the same derivative. Once again, this is the derivative function. Here's the function itself. And here's when the function is 0. And if we were to go up, what we see is when the derivative is 0, right here, the derivative being 0, when our derivative is 0, the function has a max, and let's be better language, a local max, or local min. Just for definition, please, local means in the immediate area, as you might expect. So this is a really huge idea. Whenever the derivative function is 0, my function is going to have either a local max or a local min. And we can see that right here. Visually, if we go back to the function, whenever there's a local max, it's going up and then down. When it gets to that maximum point, the tangent line has to be 0. And the slope of the tangent line. And at the local min, the slope of that tangent line, because it's sort of stopping for a second, the slope must be 0. Okay, next question. What is true when the derivative is positive? So here's our derivative function. Here's our function itself. And we've already really answered this question sort of in the other direction. The first question we answered was answered in the other direction. But when the derivative is positive, so where is that happening? For the derivative to be positive, f prime of x must be greater than 0. So that's happening here and here, because all those values are above, have positive y values. And what do those correspond to? Well, if we draw the line up, when my derivative values are greater than 0, that's corresponding to this chunk of my function. And what's true there of my function? What's true about, in all the green slices of that function? What's true? Well, when my derivative function is greater than 0, my function is increasing. And we already really developed this, but just the opposite. Going back, we said when the function is increasing, the derivative function is greater than 0. Now I'm just saying it the other way around. When the derivative function is greater than 0, the function must be increasing. And remember, this all has to do because the derivative function is the slope of the tangent line. So anywhere that my function is increasing, those are going to be positive slopes. So my derivative function is going to be positive there. Okay, what happens when the derivative goes from positive to 0 to negative? Well, we already sort of were thinking about that. Remember, the derivative is the slope of tangent line for the function itself. So if it goes from positive, that's having a positive slope. I'm looking at the function. And then it has 0 slope, so 0. And then it goes to negative slope, so now it's a negative slope. So it looks like there we should have a local max. Well, is that true? So let's go to the derivative function. So here's the derivative function, and we want to know when it goes from positive to 0 to negative. Well, here it's positive, 0, negative. Here it's negative, 0, positive. So this is the point that's of concern, because going left to right, left to right, it goes positive, 0, negative. So positive, 0, negative. And what's going on there? Well, going up to our function, as we would expect, we have a local maximum. So, putting that in words, if the derivative function goes from positive to 0 to negative, then f of x has a max. And I think we could make the alternative statement, which is if f prime of x goes negative to 0 to positive, and that's happening right here. This is a negative value. There it's 0, and here it's positive. And that corresponds to a local min. So if the derivative function goes negative 0 to positive, then f of x has a local min. So now we've developed a new way to find local max and local mins of function, which is something that you did a number of times, I imagine, in pre-calculus, and you had to use the max or min function of your calculator. But now, through inspection of the derivative, by finding when the derivative either goes positive 0, negative, or negative 0, positive, we can determine whether the function is a max or a min. So this is a nice new technique that we've developed. Okay, what happens when the derivative has a max or a min? Well, I'm going to pause this video. We're going to start a new one in a second. But this is a big idea for us, and it's a new idea. So I'm going to pause this, and we'll come back to it in the next video.